Hello, everyone. This is Dr. Rhonda Farrell, the founder of CSTGIA, bringing you week 43, Quantum Trust, Securing the Unseen Frontier. So we are at the edge of the unknowable. We stand today at the edge of a technological frontier so profound it challenges our very definition of security, privacy, and trust. Quantum technology, once the stuff of theoretical physics, has moved from whiteboards to war rooms, from lab experience to government policy agendas. But here's the question. In an era where quantum power can decode secrets faster than we can protect them, how do we build systems and societies that we can still trust? Because quantum is not just another technological trend, it's an ultimate paradigm shift in control. It upends the assumptions that have governed encryption, authentication, and risk since the dawn of computing. It asks us not to reimagine not only how we defend our data, but how we define truth itself. So the quantum disruption is deep. First, let's begin with some clarity and all get on the same page. Classical computing operates in bits, each of which can be a 1 or a 0. Quantum computing operates in qubits, which can be 1, 0, or both simultaneously. That's not science fiction. It's something called superposition. What this means is that quantum computers can process vast possibilities in parallel, transforming fields like chemistry, logistics, and most of all, cryptography. But the same power that can simulate molecules to cure diseases can also shatter encryption and compromise global security systems in minutes. We call this the Q-day scenario, the moment when a quantum computer becomes so powerful it will break current cryptographic standards, rendering decades of secure data suddenly extremely vulnerable. NIST, CISA, and global partners have already been preparing for this future through post-quantum cryptography, PQC initiatives. But here's the catch. Technology is still far outpacing adoption. Many organizations are still blissfully unaware that the systems they trust today may be completely obsolete tomorrow. The quantum disruption isn't just technical, it's existential. It shakes our confidence in the very foundations of digital trust as we know it. So ultimately, we have a crisis of confidence. What does quantum matter? Why does quantum matter so much to cybersecurity and governance? Because trust is the currency of the digital age, and trust, once broken, takes generations to restore. Imagine waking up to find that every classified archive, health record, and financial transaction that's been encrypted under today's systems could be retrospectively decrypted. Quantum decryption doesn't just steal information, it will ultimately rewrite history. This creates a new class of risk, data at rest exposure, because even if adversaries cannot decrypt now, they can harvest now and decrypt later, stockpiling stolen data for the prime quantum moment. This is not paranoia. It's already very much happening. What the NSA calls steal now, decrypt later attacks. And the longer organizations wait to modernize their cryptographic infrastructure, the more exposed their future becomes. But here's the insight most leaders miss. Quantum disruption isn't only a threat, it's a once in a century opportunity to rebuild the architecture of trust from the ground up. The unrealized opportunity is in our quantum trust framework. Let's imagine what quantum trust looks like. Not just quantum safe encryption, but a true redefinition of how trust is earned, measured, and maintained in a quantum capable world. Quantum trust ultimately rests on 4 interdependent principles. 1, integrity of algorithms. We need to replace fragile proprietary encryption models with transparent, globally vetted post-quantum algorithms. NIST PQC round 4 finalists like crystals, Kyber, and dilithium are just the beginning. Number 2, interoperability across eras. Systems must operate seamlessly between classical and quantum domains, what I call trust continuity. No technology migration should fragment the chain of confidence between past and future data. Third, transparency and governance. We need to establish cross-sector bodies, quantum governance boards to oversee standards, adoption, and ethical use. Think of this as the Geneva Convention for quantum technology. Fourth is human oversight and foresight. The ultimate arbiter of quantum systems must be human conscious. Algorithms can compute probability, but only people can discern ultimate purpose. This is the unrealized opportunity. Quantum computing does not have to ultimately erode trust. It can expand it if we use it to engineer systems that are grounded in integrity, accountability, and shared stewardship. Because quantum-ready leadership is required. We need to build the mindset before the machines. Quantum leadership isn't just about mastering physics. It's ultimately about mastering adaptability, because what quantum teaches is not just computational power, it's the power of paradox. Leaders must be comfortable thinking in superposition, holding multiple truths, possibilities, and outcomes at once. That's what leading in uncertainty looks like. So what does quantum readiness require? Well, it requires awareness. We need to understand where your critical data lives and what cryptographic standards protects it. We need to have assessments to identify what systems would be most impacted by Q-Day. We need to be thinking about acceleration, begin migration to PQC standards now, not later. We need to be advocates, championing investment in quantum talent, mathematics, physics, engineers, and ethicists who can bridge the technical and moral dimensions of this field. Quantum leadership demands multidisciplinary literacy by combining cyber strategy, ethics, and foresight, because you can't govern what you don't understand, and you can't trust what you can't explain. So we need to move from fear to foresight. For many, the quantum era feels intimidating, a looming storm on the horizon. But fear has never built a bridge, but foresight has. What if we approached quantum not as a threat to control, but as an invitation to evolve? Here's what that looks like in practice. Quantum key distribution technologies, creating unbreakable encryption using the laws of physics, not mathematics. Quantum sensors that improve national security, environmental monitoring, and disaster response, and quantum ethic frameworks that ensure equitable access and prevent digital colonization by a handful of nations or corporations. These aren't science fiction. They're happening now in programs across the United States, the EU, Japan, and Singapore. The future of quantum isn't just about who builds the biggest computer, it's about who builds the most trusted ecosystem. So let's integrate quantum trust into cyber governance, because quantum transformation cannot be left to scientists alone. It demands governance convergence, integrating policy, risk management, and human values into every layer of design. NIST 2023 AI, RMF, and the upcoming post-quantum cryptography migration playbook offer phenomenal starting points, but we also need quantum ethics boards to evaluate global implications, from surveillance to inequitable access to computational advantage. Incorporate quantum readiness now through cybersecurity frameworks, CISA, ISO IEC 27001, procurement policies that are quantum safe by default, workforce development, where we cross-train cyber analysts in quantum principles, and public trust programs for citizen education on digital sovereignty. Because quantum trust isn't built in data centers, it's built in communities that believe in fairness, transparency, and shared accountability. So our strategic takeaways for preparing for our quantum reality is to start your post-quantum roadmap now. Inventory systems, classify vulnerabilities, and engage vendors on PQC adoption. Educate your executives and boards. Decision makers must understand both the risks and the strategic advantage of quantum readiness. Collaborate globally. Quantum resilience requires shared standards and cooperative research. No nation can go it alone. Integrate ethical guardrails. Create a quantum trust charter, a declaration of principles that guide responsible innovation. And lastly, invest in human wisdom, because as technology evolves, values must endure. And we need to embed foresight into every algorithmic decision. So in closing, we need to be thinking about trust beyond time. Quantum technology collapses the boundaries between what is possible and what is knowable. It asks us not to fear complexity, but to evolve our definition of certainty, because the future won't belong to those who control the most data, but to those who command the most trust. Quantum trust is that command, the ability to lead through uncertainty, to see the invisible, and to design systems that endure across generations. So as we enter this new frontier, let us remember our greatest encryption will never be mathematical. Ultimately, it will be moral. And the strongest quantum key we'll ever hold is the one that unlocks our collective wisdom. Again, this is Dr. Rhonda Farrell, the founder of CSTGIA, bringing you week 43 of Quantum Trust, Securing the Unseen Frontier.